Hi everyone. In this lesson we're going to be working with rigid motions and their properties to determine if figures are congruent. So we're going to be working today with rigid motions and congruent figures. And we're going to start by reviewing the definition of what a rigid motion is. A rigid motion is a transformation that preserves lengths of segments and measures of angles. And these two properties are the two very important properties of rigid motions: preserving the lengths of segments and the measures of angles. So whenever the question asks you to use the properties of rigid motions, you have to mention these two properties: preserving the lengths of segments and measures of angles. You have to mention those two properties. And then we're going to look at this new definition, which is the definition of what congruent figures are. And figures are congruent if one can be obtained from the other by applying a rigid motion or a sequence of rigid motions. So figures are congruent only if they come from another figure through a rigid motion or a sequence of rigid motions. So with that in mind, we're going to go to exercise number 1. And exercise number 1 says, in the diagram below, triangle ABC is congruent to triangle DEF. Describe a sequence of rigid motions that maps triangle ABC onto triangle DEF. So here, one word, maps. Mapping means moving from one place to another. So it says moves. That's what it means. You will see this word a lot, especially on regions questions, but that's what it means. So describe the sequence of rigid motion that moves triangle ABC to triangle DEF. Now notice here some important things. They are already telling you that the triangles are congruent. So the question is not whether they are congruent or not. They are already telling you that the triangles are congruent, which means that because they are congruent, there should be rigid motions here. And that's why they are asking you just to describe what's the sequence of rigid motions that maps triangle ABC onto triangle DF. So they are already congruent. There should be rigid motions here. Your job is just to find and describe what those rigid motions are. So if we look at the diagram, we're going from ABC to DF, to triangle DF. How can we get from triangle ABC to DF? There could be different ways to do it. For example, one of the ways could be to reflect this triangle ABC on the y-axis. So that would end up here on the first quadrant. And then from the first quadrant, you could translate down and you would end up with triangle DF. So I'm going to just sketch that very briefly. So if you reflect on the y-axis, you would end up with this triangle here, like that, where this would be B prime, A prime, and C prime. So we are reflecting on the y-axis. I'm showing the reflection with an arrow, with a curved arrow, just to show that you are flipping the figure on the y-axis. And then we are moving this triangle downwards, we don't know exactly how many units because we don't have a grid. But if we do that, we will have triangle DEF as the result. And there could be another way. For example, you could translate first here, translate triangle DEF, and if you translate downwards, you will have the figure now on the third quadrant, and then you would reflect on the y-axis and you will have the same triangle DEF as the result. So there are different ways. In any way, there is a reflection on the y-axis and a translation downwards to get to the final result. So I'm going to keep this one, and now I'm going to describe what the rigid motions are, which should be the writing, of course. So it would be a reflection on the y-axis followed by a translation downwards. We always try to be as exact as we can. So we say where was it reflected? It was reflected on the y-axis. And how was it translated? We're just saying downwards because we cannot know how many units down it was translated. But if you had a coordinate plane, you should say how many units down was it translated. In this case, we cannot say that. So that will be the description that we are being asked for. And we're now going to exercise number 2. In the diagram below, triangle A prime, B prime, C prime is the image of triangle ABC after a sequence of transformations. Is triangle A prime, B prime, C prime congruent to triangle ABC? Use the properties of rigid motions to explain your answer. So compare the two questions here. They are very different. In number 1, they're already telling you that the figures are congruent. Here, they are not telling you that. They're actually asking you if the figures are congruent or not. So here, because the figures are already congruent, we know that there should be rigid motions. Here, in number 2, they are just telling us that one triangle is the image of the other after a sequence of transformations. They are not telling us that those transformations are rigid motions. You have to find out if there are rigid motions on the diagram or not. Because if there are rigid motions, then you could say that the triangles are congruent. But we have to find out if there are rigid motions here or not. And if I would say to justify, you need to mention here the properties of rigid motions. You have to use them, those two properties, on the explanation. So you use the properties of rigid motions here to justify your answer. Remember that the properties of rigid motions are preserving the length of segments and the measures of angles. These two things must be mentioned on the explanation in question number 2. Okay, so let's look at the diagram and examine it to see if there are rigid motions or not. So I look at triangle ABC. We're going from triangle ABC to triangle A prime, B prime, C prime. And if we compare just by looking at it, we can see very clearly that the figures look exactly the same size and the same shape. With regards to size, you could even compare here how many units do you have, like from point A to B, you have 1, 2 units, and the same thing happens from A prime to B prime, 1 and 2. From B to C, we have 3, 3, and from B prime to C prime, we also have 3, 3, and from A to C, we have 2, 2, 4, 5, and from A prime to C prime, 2, 2, 4, 5, which just proves that the size or the length of the segments are the same. So that means the length of the segments have been preserved. And you could see by the shape, which is the same, that the angles also have been preserved. So that means these are congruent and that there should be rigid motion. So now that we see visually that they are congruent, we should now find what are the rigid motions in order to support our answer of saying yes, they are congruent. So what are the rigid motions? Very similar to what we did on number 1. You could reflect triangle ABC on the y-axis, and that would end up here in the second quadrant. And then you could move down to get triangle A prime, B prime, C prime. So I'm going to do that reflection right now, or you could do, of course, the other way, which would be first translating and then reflecting. Any of those two is correct. So if I reflect on the y-axis first, the value, I would say point A, is 3 units to the right to reflect it. The reflection of A should be 3 units to the left. So here would be the image of A. And then we have B, which is 4 units to the right. So the image of that point should be 4 units to the left. And then we have C, which is 1 unit to the right. So the image should be 1 unit to the left. Okay, just approximating. And if I connect them, should look more or less like this. Okay, and then so we have reflected on the y-axis, and then we can translate. In this case, we can see that the translation is 3 units down because we can count here since we have the grid, and that those would be the 2 rigid motions that we have: translation and reflection, or in this case, first the reflection and then the translation. Remember that translations, reflections, and rotations are rigid motions because the image and the pre-image look exactly the same. So we are now going to answer the question and explain using the properties of rigid motions. So first we're going to say, yes, triangle ABC is congruent to triangle A prime, B prime, C prime. So let's write that. Triangle A prime, B prime, C prime is congruent to triangle ABC. So you need to answer the question that you were asked. And then we explain using the properties of rigid motions. So we start the explanation with because. So why do we say that triangle A prime, B prime, C prime is congruent to triangle ABC. We're going to explain here. And we're going to say it like this. Triangle A prime, B prime, C prime is congruent to triangle ABC because triangle A prime, B prime, C prime is the image of triangle ABC after a reflection on the y-axis and a translation of 3 units down. So up to that point, we are just telling what are the rigid motions that we have. So let me write that first. Because triangle A prime, B prime, C prime is the image of triangle ABC after a reflection on the y-axis followed by a translation of 3 units down. Okay, so right now we have answered the question and we have basically just a starter with the explanation, but we're not finished with the explanation because up to this point we have only identified what are the rigid motions. We still have to mention the properties of rigid motions. Okay, so now we're going to continue. Now we're going to say that reflections and translations are rigid motions because they preserve the measures of segments and angles. Those are the two properties, which makes the triangles congruent. So continuing, reflections and translations preserve the measures of segments and angles therefore the triangles are congruent. And that's how we finish number 2. So triangle A prime, B prime, C prime is congruent to triangle ABC because triangle A prime, B prime, C prime is the image of triangle ABC after a reflection on the y-axis followed by a translation of 3 units down. Reflections and translations preserve the measures of segments and angles, therefore the triangles are congruent. So here we have mentioned the properties of rigid motions, which were required to do as part of the explanation. Okay, so that's how we work with the properties of rigid motions in order to show that the figures are congruent. I'm going to leave exercises 3, 4, and 5 for you. Exercises 4 and 5 are on page number 2. So complete them and email them to me. So that's it for today's lesson.